as AI agents are becoming more and more mainstream, fragmentation is really becoming a big challenge. But this fragmentation problem in AI agent ecosystems may finally have a solution. A standardized protocol stack for agent to agent communication is now under the Linux Foundation governance, and the technical implications are really significant. Today, we are diving into AGNTCY, the open source infrastructure project defining common standards for discovery, identity, messaging, and observability between AI agents across frameworks and vendors. Originally launched by Cisco's Outshift team in March, agency has rapidly grown into a community-driven initiative with more than 75 contributing organizations including Dell, Google Cloud, Oracle, and Red Hat. Joining me today is Vijoy Pandey, SVP and GM at Outshift by Cisco, to walk us through agency's architecture, the interoperability challenges it's addressing, and what it means for developers building in the AI native stack. Vijoy, it's great to have you on the show.
It's great to be on board, Swapnil.
Let's start with some of the basics. Let's start with the architecture. Outshift, as we all know, has been incubating emerging technologies for some time now. What is the mission of Outshift, and what specific challenge led to agency?
Outshift, it's an internal incubator at Cisco, just like you just said. And think of us as a whole bunch of startups within Cisco. So we're all Cisco employees. We are bona fide Cisco badge holders. But the way we operate is like a bunch of startups. So we have everything from engineering to ideation to product management to marketing to customer success and support, all of that rolled into the organization, even though it's small, it's not at the size and scale of Cisco. And the whole goal is for us to go after adjacent market opportunities for Cisco. And adjacency comes in two ways. One is you can think of personas that are adjacent to Cisco's current personas. So these could be the user, practitioner, or buyer personas. Or adjacency could be in terms of technology and market. So we look at things that might have technology risk or a little bit of a market risk. And we think of ourselves as a job of reducing risk for Cisco when you enter new markets. So we've been looking at, like a few years ago, we looked at cloud security because that was net new and cloud native was all net new. And now with agentic and AI coming in, we're looking at this whole space of Internet of Agents and agentic AI. And we're also looking at quantum networking and quantum security. So those are the two big swim lanes for us.
As we all know, agency supports discovery, identity, messaging, and observability. Can you walk us through, and if there are more, can you just walk us through what that means in practice? What protocols are being used for agent discovery, and how does this incorporate across different frameworks? Because that is one of the challenges we are trying to solve here.
I think the way it started out, so this whole notion started out, I would say, roughly 18 months ago, 15 to 18 months ago, when we as a company and Outshift as well as Cisco, we started integrating and incorporating agentic software into our environment. So both from the product build side, as well as from the IT and consumer and consumption side. And so the challenge, which is pretty well known today, is if you think of a larger goal, you can't have a singular agent come in and solve for that larger goal. There is a paradigm shift happening in computing. We are moving from deterministic computing to probabilistic computing. And the way that is being handled is these agents, which are supposed to be subject matter experts. So instead of having one big, large, one-shot, zero-shot agent, you have these subject matter experts that all need to come together, collaborate, and solve for the larger goal. And this was shown by Eric Brynjolfsson, who's an economist. It was then later picked up by Andrew Ng, who showed this to be true in the software development life cycle. And now we see this to be true everywhere. And when you think of these agents coming together, even though the world is obsessed by software development right now, Really, if you think about agents, they will span a whole bunch of verticals. So they're going to span B2B software, B2C software. They're going to span services. They're going to sit in scientific discovery. So, like when you're doing protein discovery and drug discovery, you're going to have foundation models there and agents there. You're going to have foundation models and agents represent avatars in social networks. You're going to have these things sitting in embodied form in physical AI. And so all of these agents will have to come together. And so you needed a platform to bring all of these things together. And that's where the whole concept of the Internet of Agents was formed. Now, you brought up the discovery and all of these problems, and I'll come to that in a second. But if you think about this broad problem, where if you think about drug discovery, you will bring agents from physical AI that are doing wet lab experiments. You'll bring agents that are doing protein folding exploration. You'll bring agents that are doing planning and composition for you, which are LLMs. All of these disparate things together, you will see that agents will come from different vendors. They will have different capabilities. They'll take on different personas and identities. And you really need a true internet to connect all of these things together. So the architecture, coming back to your question, truly has to be multi-vendor, support multiple clouds, support multiple organizations, but also unlike software, it needs to evolve because the same instance of software, because it's agentic, is not static. It depends on the environment in which it's running. It depends on the time when it's running. So based on the data you're feeding in, based on the prompts that you're feeding in, it behaves very differently. It's not a static piece of software. So we wanted to build this platform that actually handles all of that. And what we realized is that there are four phases. The four phases of discovery and identity in any life cycle. So discovery and identity. Then you get to composition. So I've discovered my agents, I've given them some identity and authorization. In fact, these authorizations are also not static, they're task based. And then I compose them in a workflow, starting with a workflow which is deterministic, but eventually it might be more dynamic. Then I deploy them at scale. So the whole deployment cycle and how do we make them communicate. And then finally, the observe and evaluate. So are they really doing what they're supposed to do? So that entire life cycle is what agency is trying to tackle or Internet of Agents is trying to tackle. And that's the problem that we're after.
Let's just talk about moving agency under the umbrella of Linux Foundation. Can you talk about, first of all, Linux Foundation? They have great governance that is accessible to all the projects, but talk a bit about the governance of this project. Just talk about the organizational structure, then we'll talk about the technical part later. But let's just talk about what this contribution or donation to Linux Foundation actually mean. What does the project look like under the Linux Foundation umbrella? Is it part of a bigger foundation? Is it its own foundation? Just talk about the organizational structure of agency under Linux Foundation.
Yeah, so I think so. The first of all, the rationale, like you said, right? So why even move it to the Linux Foundation? And I know you've been in this space for a long time. I mean, you've been in the cloud native space, especially for a long, long time. And it's a similar thesis, right? I mean, it's Kubernetes used to belong to Google, and Google donated it to the CNCF, and then there's a whole ecosystem that formed around it. And now, if you look at that CNCF map, there are like hundreds of logos on there, and there's so many startups that actually formed from the CNCF set of projects. And so, like you said, I mean, LF has done a pretty good job in a whole bunch of spaces. Of course, with the Linux OS itself, starting from there with CNCF, with OpenSSF. I mean, we've been involved in a whole bunch of these foundations and projects as well. So that's why we picked Linux, because they have the neutrality of governance, but also the might. I mean, communities, yes, they do happen bottom up, but you need the might and the resources to nurture and grow that community. And I think the LF has that might and the resources to actually grow the community. And that's the one big reason why we picked, another big reason why we picked the LF. From the structure perspective, when we formed the project initially back in March, we had LangChain and Galileo as our founding members. And since then, we've added like 75 plus contributors to the project. So it's a pretty big community at this point. But as we go into the LF, we wanted this to have a lot more weight. And the other thing is we wanted this to work well with some other projects that are coming into the LF as well. So you saw two things happen. First of all, the 5 founding or formative members, like we like to call them, in the LF for agency are Cisco, Dell Technologies, Google Cloud, Oracle, and Red Hat. And so there's a good mix of large cloud players, vendors, and a big open source based company as well, Red Hat, so which keeps us all honest. So that's the structure, and all of these 5 companies are now part of the TSC, or the Technical Steering Committee. So the future of agency will be decided, technically will be decided by these 5, primarily, and also by the host of contributors and maintainers that exist in the projects that we have, like the discovery, identity, messaging, and so on and so forth. So that's the structure, I would say. The other big thing why we went with the LF, and we announced this along with Google about a couple of weeks, a month ago, which when Google donated the A2A, or the agent-to-agent protocol, to the LF, we were a founding member, a formative member of the A2A project as well, as it went into the LF, along with others like Salesforce and ServiceNow and AWS and Microsoft. So what you see here is A2A being donated to LF, agency being donated to LF. And if you look at our blog, we are talking about how A2A and agency are complementing each other, because we are not about specific protocols. We actually, agency integrates today with A2A, it integrates today with MCP. So when you think about agent-to-agent communication, that's A2A. When you think about agent-to-tool and agent-to-data sources protocols, that's MCP. And that is shown in our architecture diagram, and we are building around it. Those protocols themselves are not enough. You need the OSF, the schema framework, to describe these things. You need the directory to discover these things. You need the identity to provide identity, not just to singular agents, but to multi-agent frameworks. And so MCP servers belong in the agent directory for agency today, as an example. MCP is a part of the architecture. We have a messaging layer called SLIM, which stands for Secure Low Latency Interactive Messaging. MCP runs on that, A2A runs on that. A2A is also integrated into the directory. So as you go through the architecture, you'll realize that is a singular whole here. And we are being complementary to what already exists. And we are providing the missing pieces around it to actually provide a working stack for somebody who's actually building not just agents, but multi-agent architectures. And you can't just do that based on protocols. We need everything else around it. So that's the thesis. And as we move forward with the LF and with A2A, you'll see these things actually coming together even better.
What technical specifications are being standardized as you move agency into the Linux Foundation? We already talked about the organizational structure, but how does this governance model will also ensure protocol compatibility across different implementations?
So right now, the agency architecture is actually inclusive of what we call the OSF, the Open Agent Schema Framework, which is a schema definition which is pretty extensible. And we started that way. There's very little in the core, and it's all extensions, because none of us really know where this thing is going to evolve. So we want the community to help evolve this. And the OSF helps you define what you can search for. So it could be agents, it could be multi-agent apps, because what is an agent? It could be a foundation model with access to tools. It could be many foundation models to access to many tools, many agents talking to each other within one blob. So agent is a little bit of an ambiguous sort of definition. And so we wanted OSF to be as flexible as possible to define agents in many ways as possible. So you can define agents, you can define multiple agents within a singular blob. And you can define MCP servers, because that's almost like a tool access, which an agent could be a tool if you squint. So it's all very related. So it's pretty flexible there. Also, what we are saying is that OSF is going to be extended towards physical AI and so on and so forth in the future. So we're keeping it pretty open-ended. So that's OSF, which is the schema framework. Then we have the agent directory. And the agent directory is, think of it as a collection of OSF entries. So you have all of these definitions and you collect all of this in a directory. And the way we've architected the directory, and this is crucial for us, is we truly believe in open and interoperable, which means we don't want things like directory, which is like the DNS for this new Internet of Agents, and identity, which I'll talk about in a second, which is like, again, a VeriSign for the Internet of Agents. We don't want these critical pieces of infrastructure to be owned by a singular entity. So the directory, as an example, has been built with decentralized principles in mind. So it uses things like libp2p, it uses distributed hash tables. So you can truly, like, no singular entity owns it, and it is truly decentralized in its nature. And so not just distributed, but decentralized. So that's directory. And you can leverage directory to search for agents internally within an enterprise. You can mark them private, agents externally, as well as MCP servers, which are like tool endpoints and so on. So that's the directory. Along with the directory, we released identity. And so again, I said identity is also decentralized and all of that. It cannot be owned by a singular entity. That's our belief. But identity also is solving a whole bunch of new problems in the agentic space. So the problems could be as simple as, when you think about agents, agents are like humans, but operating at machine speed and scale. Because they talk in non-deterministic ways. The outcomes are non-deterministic. You're exchanging multimodal information. So it's not just a JSON. It's like you're sending audio and video and images and all of those things. So in that era, when agents are humans operating at machine speed and scale, what is a task and how do I give authorization for a task is a pretty open-ended question. And today's authorization schemes actually do not solve for those kinds of questions, because they have been built for humans or they have been built for machines and software. And so when you blend these things together, and when you think about task-based access control and authorization, that becomes a pretty interesting problem. And what is a task is actually a pretty interesting question that we can spend hours on. So identity and the identity plane agency is actually solving for those kinds of things. Then we move on to messaging. And so agent-to-agent protocols, yes, we're showing A to A. You can integrate anything in the agency architecture. Similarly, we are showing MCP to tools, and people think that's de facto at this point. But if somebody comes up with something better, you can integrate any protocol in that architecture. But what we are providing is a layer of messaging called SLIM, which stands for Secure Low Latency Interactive Messaging. This is a layer that allows for many-to-many communication that is not possible today in standard gRPC. So it's built on gRPC, SLIM is built on gRPC, but it provides many-to-many communication. It provides real-time interactive behavior, because that is critical for agents that are dealing with voice and video. And it provides for scale at real time for many-to-many, and it layers post-quantum cryptography above it. Because we want all of this communication, because we're starting from scratch, let's make sure that it's post-quantum safe. And that is a core belief of us, because if you think about where some of these things are headed, like iMessage has PQC enabled, Chrome browsing has PQC enabled. When we're building agents and agent communication, we want all of that to be PQC enabled as well. And so by providing this in one layer and integrating A to A, MCP, and anything else that comes above into this layer, we offer these services for free. Because if you use SLIM, you get all of these things by default. So that's messaging. And finally, we come to observability and evaluation. So how do you observe not just singular agents, but these multi-agent workflows. And some of that actually we are pushing into open telemetry as well. And some of that is beyond open telemetry, we are bringing to agency. And how do you evaluate these things? So how do you ensure that they're doing what they're supposed to do? So that is the architecture as a whole. But again, each one of these things is available as code, is available as specifications. And in fact, two of these, identity and directory, are also available as a service in agency. So that's available today.
Excellent. Once again, thank you so much for explaining in detail. The viewers are going to really love it. Now, when we talk about, let's move from the project to actual enterprise deployment. At enterprise scale, performance becomes very, very critical. How does agency handles agent-to-agent communication across very, very large distributed environments?
That's the thing that we actually try to solve through a bunch of these architectural principles, as I just explained. So making sure that the directories, so the discovery mechanism and the identity mechanisms are decentralized in nature, makes it scalable right from the get-go. Because you can actually scale to trillions of entries because we are highly decentralized. And that's where we are headed in the world of agents. So if you start with, I would say, normal, in quotes, distributed computing principles, you can maybe go to millions, but agents are going towards trillions. Because every human, every enterprise is going to have multiple agents. In fact, tens or hundreds of agents represent them in the future. So the architecture that we want to build right from the get-go needs to be scalable to that level. So that's one aspect. And the other aspect, like I said, is on the messaging layer. Because the kinds of communication that you're dealing with, why is agent-to-agent communication different? It's different because A, they are probabilistic and not deterministic. It's different because they are multimodal in nature, because you're handling audio, video, images, and so on, not just text and code. And it's different because these agents are actually going to work with each other in teams. They're going to get into negotiation loops. They're going to get into finger pointing in some ways. They're going to get into conflicts because they're going to say, I can do it, but maybe that agent can do it better. And so how do you know what kind of an architecture or workflow makes sense? So how do you handle these loops is the other problem that we're trying to solve in that messaging layer. So security, multi-agent communication, many-to-many communication in an efficient manner, because you don't want to burn the network, making sure that it's low latency and interactive, because that's what most of these agents will require, and making sure that you handle these simple things of handling loops and negotiations and conflicts in the framework itself is the way we're handling scale and performance in the architecture. And of course, there's observability and evaluation, but that's standard distributed computing principles.
Earlier, you were giving some example about agent to agent. Now, we know, Outshift agency, it has been around, but though it's contribute to Linux Foundation now, it's still early from the perspective of a Linux Foundation hosted project. But are there any initial or emerging use cases that you can share where agency is already being explored and piloted? The beauty and the challenge with open source is in most cases you don't even get to know because it's all open source. But at the same time, just the way Linux kernel is a great example, the reason Linus created it and now the reason it's being used is beyond his own imagination. So we cannot even say where it's being used. But what are you seeing or where do you see it?
So I'll give you 4 examples because that is actually the proof is in the pudding question, right? And
Proof is in the source code.
yeah, proof is in the source code. You're right, and I think so. I'll give you 4 examples, and they're all different. And and you're right. I mean, in some ways things are a little early, but also it's rapidly moving, as you can imagine. So the 4 examples I would provide is one is from our partner. So what better way to talk about something than somebody else who's using it to build out their product and their market. So one of our partners and contributors, SoftServe, They publicly talked about it last week itself. They are building voice agents. And a lot of the questions that you've talked about in terms of scale are actually valid for them. So they have built a multi-agent application in the voice domain, working with WebEx, which is our collaboration unit. And you can, I mean, instead of me talking about it, you can actually, the listener can actually go and read their blog about it, where they talk about why agency and how it has helped agency, how agency has helped them build that really critical interactive multi-agent voice solution. So that's one example. The other example I would give is we've actually donated an open source implementation of a product or project that we built internally. And this is should be very familiar to you as well. We're calling it the SRE engineer or AI platform engineer. And there's a working group called Cloud Native Operating Excellence, CNOE, canoe.org. And there are members from, of course, Cisco, there are members from AWS, Adobe, a whole bunch of places. These are SREs from all of these organizations that come together and talk about their pain points and how to solve their pain points. I mean, it's as simple as that. And I feel SREs have the toughest job in engineering. So they come together and talk about these things. And we built this piece of software internally. We call it Jarvis, which is not very imaginative. But when we donated it, we are calling it the AI Platform Engineer. And it is a multi-agent app. It has 20 plus agents, which can be configured in different kinds of workflows. And it actually integrates with 5 plus interfaces. You can access it through a UI, CLI, through a chat interface like WebEx. And it has reduced, at least I can talk about it from the Outshift perspective, which is a pretty small team. And I can talk about it publicly. We are also using it within Cisco. But it has reduced work for the SRE team by 3 FTEs. And we don't have a big team. So 3 FTE worth of work has gone away. Query responses to the SRE team has gone from days and hours to minutes. And we have pretty much automated or obsoleted 30% of the workflows that SREs do. And our goal is to get to 50% by the end of this year. So it is truly, the proof is in the source code. And in this case, the source code is actually open source as well. So you can take a look at all of these and figure out how you can leverage it as a design pattern or even as a project within your organization. So that's the second example. The third example I would give is a proprietary one, which is we have worked with a bunch of telecom providers to build a network configuration automation validation test tool. So that entire pipeline where you either build a new network, you migrate networks or devices, you change the architecture, you do repairs, all of that entire network configuration validation and test pipeline, we have built that in a multi-agent manner using agency. And that is something that we've worked with, and this is public, so I can talk about it. We've worked with one of the telecom providers is Swisscom, but there are many other telecom providers that we've worked with them on. So that is a proprietary tool because it's a business that it brings to Cisco. And so that is, again, using agency. The fourth example I would give is actually a bigger one, potentially, which is we just open sourced this reference app called Coffee Agency. And so if you remember, in the cloud native days in CNCF, there was a reference application called SockShop. And so SockShop was this online shop, where you could go and buy socks. But it's basically leveraging the entire CNCF ecosystem in an open source way so that people can play around with the different open source projects that exist in the CNCF ecosystem. So tomorrow, if somebody brings in a new project, or tomorrow, if somebody wants to try out Scale, or tomorrow, if somebody wants to plug in a proprietary piece of code, they have SockShop as a reference open source implementation of a large, scalable, cloud native product or project that you can play around with. We've done the same thing with Coffee Agency. So the Coffee Agency is a large multi-organizational, multi-vendor, geographically distributed multi-agent application that we've open sourced. And you can buy coffee. So it's a coffee shop, but it integrates A2A, it integrates agency, it integrates MCP. And in the future, it'll integrate a whole bunch of other open source that you can then play around with. And you can do your own testing and your own validation. And we believe that this is the most important piece of code that we're going to open source.
The fact is that we will continue to live in a kind of hybrid world, some open source, some proprietary. More open source is always good, but it's really good to see more open source coming out of Cisco. So thanks for that. Not only thanks for answering the question, but also thanks for releasing more code in open source. Now, I was listening to you, and especially the use cases and the ecosystem that you have built around agency with such a large and diverse contributor base, which is problem and good thing with open source. How are you also approaching interoperability across agent implementations? You touched upon it briefly, but I want to go just particularly in detail, especially when they are building, you named different frameworks like LangChain or their own internal stack.
So the framework one is actually the simpler one, because the framework one, the way it's handled is all of those, I would say, 4 main open source frameworks. So LangChain, Llama Index, Crew, and AutoGen, or the AG2 folks, they're all members of the contributor base for agency. And so they have provided extensions to the various protocols that exist and the various open source components that exist within agency. So it interoperates out of the box. I think what you're asking has bigger ramifications in the future, where as more and more open source appears, I think the challenge will be there. The challenge will be, like, we have tried to cover things that exist, right? So we've tried to cover MCP and A2A, and we're working with OpenTelemetry on the observability side. We're working with the identity providers like Duo and a bunch of startups, and we are working with some other big companies as well in making sure identity is managed. But that's the state as of today. But as we all know, that this agentic space is going to just explode even more. And so I don't have a great answer to that, but we just have to keep up with all of that. And that is also one of the reasons why we went to the LF. Because as even though we were trying to run this with LangChain and Galileo and the 75 contributors, the scale that we need to manage such a community, I think that only comes with a Linux Foundation like entity. And so that is one of the big things, the reasons as well. And over time, we hope that as more open source comes up, they also join the Linux Foundation. So then it's easier to manage within the premises of that. But that's an open question, and we'll see how that evolves.
Yeah, one thing that Linux Foundation has done excellent, and I have been covering Linux Foundation even before the Linux Foundation was formed, was that it's not just about code, it's about building a community. And now this community is not just the community of developers who are writing the code, but sometimes people, when they say open source, there is no open source community, there are communities. So there are communities of contributors, as you mentioned, 5 founding members or whatever term you want to use, and then there are the whole maintainers, then the users, and then vendors who are using it to create. So it's like a trade organization which is helping. I always say that Linux Foundation is the one, or Linux is the one that made organizations like Cisco get comfortable with open source. Otherwise, we used to use the term free software, which led to a lot of confusion that it's a free cost or something. So they have done a great job. So yeah, it's good to see more and more projects move into the Linux Foundation. Now, I also want to talk a bit about looking ahead. What's on the technical roadmap for agency? What are the priorities you have immediate one, long-term one, what are the challenges, how you see. I mean, now the cat is out of the box, so you don't have much control about how the project will evolve because the community will decide that. But just give us a glimpse of the technical roadmap.
Yeah, I mean, I think so. You're right in one way that now the roadmaps are going to be more public and more driven by communities. So we'll see how that evolves. But I think from the top of my head, where I see the pain points, I think what we realize from our user base, like you said, is the identity problem is actually the biggest problem today. And so security, identity, authorization, that to me is the biggest problem. And related to that is the discovery problem. But I think we flipped that narrative a little bit because we used to think that you want to first discover and then look at identity and auth. And that is still true because as I build my app, like which are the agents I want to pick and choose to build my app. But it's actually turning around a bit because to drive enterprise grade adoption, identity authorization and security are becoming the key problems to solve. So I think you'll see a lot from us and everybody on identity authorization, but also at the slim layer. Like you asked that question, performance and scale actually are now becoming important. And so that slim messaging layer to us is the other key problem that we want to push and solve for because it provides security for like PQC for all communication, whatever protocol you happen to use, and it provides real-time interactive behavior for many to many. And that's a real enterprise grade requirement. So that I think is the second big one that I think we'll need to solve. And then an overarching, not just an agency, but I think an overarching problem statement is the whole notion around AI security. So AI security as a whole, whether it's agent security, AI, like traditional AI security, data security, all of that is a big, I would say, umbrella to solve as well. But that's independent of open source and agency, and that's a separate thread. But these are, I think, the three things where we are sort of focusing on.
And for those developers or architects who are looking to get involved or contribute or get hands-on with agency, and also what kind of folks you're looking at getting involved at this stage, and what is the best place for them to get started?
Yeah, so we are actually, I mean, one of the things why, and you said this so well, but one of the reasons to run open source project is so that you have developers, you have vendors, you have operators, and you have customers and consumers. You want all of them because that an open source and open interoperable, and this has been a belief for Internet of Agents, that an open interoperable internet drives maximal value for all of those four personas. And that's what we want. So we want all of the above because you can contribute code, but if you're not using it, then what good is that contributed code? And if you're using it and if you're filing bugs, and if you're even if it's just a consumption or a documentation bug, please go ahead and do that because that helps improve the code. So I think, and then we want these services to be built on this code and being offered by operators as well. So we want all of these folks to be involved. And the place to go is AGNTCY. Since we are cool, we drop the E. And it's a play on agents getting agency. So it's AGNTCY.org. So that's the place to go. There is a join button that you can press, and we'll just add you to a Slack channel that we have. You have access to code without even joining. So go ahead and browse the code. You can browse the documentation. We have Coffee Agency there now, so you can look at a reference application. So it's all out there. But if you join and if you join the Slack channel, you get support as well. So that's the way we think about this.
Vijoy, thanks for the deep technical breakdown. As AI systems become more autonomous and distributed, agencies protocol stack could play the same foundational role for agent communication that TCP IP did for the internet. Vijoy, thank you so much for these great insights, and I look forward to chatting with you again. Thank you.
Thank you so much, Swapnil. It was a great conversation.